In this video, we are going to move on to our next big data structure, which is a linked list. If you were going to make a collection of all the different topics frequently seen in engineering interviews, honestly, I would expect to see linked lists at the top of that collection. It's a subject that is seen very frequently in engineering interviews. So with that in mind, we're going to be spending a pretty good amount of time in this course to understand linked lists and exactly how they work. We're going to first start off with a practical definition of what they are. Then we will put together our own custom implementation, and then we'll finally tackle a handful of common interview questions that involve linked lists. So without further ado, let's take a look at a handful of diagrams that will help us understand exactly what linked lists are. So a linked list is an ordered collection of data. The collection contains a number of different nodes. And so on the screen right here, you can see 4 separate nodes. Each node contains some amount of data along with a reference to the next node. When we put a handful of these nodes together, we refer to it as a linked list because it quite literally is a list of linked nodes. We'll also very frequently refer to this as a chain or a chain of nodes that are strung together. The list of nodes that form this chain has an order that is always maintained. So in other words, the order of nodes in a linked list won't suddenly or randomly change, unless we specifically want to change it, of course. In every linked list, there are always 2 special nodes. Now I'm going to move the diagram forward, and we're going to look at some terminology that is commonly involved with a linked list. So the 2 special nodes that you'll always see are the head node, which is always the very first node of a linked list, and the tail node, which is always the very last node. The tail node can always be identified by the fact that it does not have a reference to any other node. Also notice that every single node that we're showing here has 2 discrete parts of it. It has this kind of data bucket assigned to it. The data that can be contained in the node can be absolutely anything we want. So it can be a string, as is shown here. It can be a number, an array, an object. Any type of valid JavaScript value can be contained within one of these nodes. The other part of a node is a reference to the next node along the chain. And so with all this discussion of references, you might be wondering exactly what I mean by a reference in the JavaScript world. So without going any further, let's flip over to a code notepad very quickly, and we're going to put together a quick implementation of a very small linked list. And that will give us a better idea of how these things work. So over in my code editor, and this is very quick, you don't have to write this code out because we're just going to write a few lines of code. We're going to create 2 separate nodes of a linked list and then join them together. So I'm going to create a new variable called node1 and assign it an object with a property data that has value 1, 2, 3. I'll then create a second node that I'll refer to as node2. This thing will also have a property called data that will have a value 4, 5, 6. So I have now created 2 separate nodes here, node 1 and node 2. They are not linked together in any type of linked list at all. To link them together, I have to explicitly form a reference between the 2 of them. And so I can do that by writing something like node1.next equals node2. So now if I wanted to figure out what the first node of the chain was, it would definitely be node 1 because node 1 contains a reference to node 2. And so if we look at the diagram over here, let's flip over to right here, we kind of have a structure like this, where node 1 is on the left-hand side and it has a reference to node 2 on the right-hand side. Notice that node 2 does not have a reference to any other node, so it must be the tail node of our linked list. I want you to also notice the fact that I assigned the data for both of our nodes to a property called, quite literally, simply data. Now there's nothing special about the data property, right? There's nothing special about the fact that I called it data in both the nodes right here. I could have just as easily called it information or record or banana, whatever you want to call it. But by convention, we usually call it data. The reference to the next node was stored under the property next. And so just like data, the next property here, the name of it is completely arbitrary. We could have called it next node or chain next or chain ref or next ref, whatever you want to call it. But again, by convention, we usually call it next. So by convention, we usually make sure that every node has exactly two properties, the data property and the next property. When we put together our own custom implementation of a linked list, we're going to make sure that our nodes have both exactly properties named data and next. Okay, now the last thing I want to mention here about this very quick linked list example is that this is a very straightforward and simple implementation of a linked list. This really is a linked list right here. Notice how there's no arcane or special code that I had to write to form a linked list. No, as long as you have some separate pieces of data and then you form some type of connection between them, you can refer to that as being a linked list. This meets all the rules of a linked list. All right, I think that's enough on linked lists for now. So in the next video, we're going to jump immediately into working on our own JavaScript implementation of a linked list. That might seem like we're getting into it very quickly, but trust me, the easiest way to understand a linked list is to attempt to implement one on your own. So with that in mind, let's continue in the next video.